Luke is here. Let me get my participant list open and we will get started. Oh, yep. I can do that. I'm sorry. I thought I think I put it on my YouTube account, but I didn't put the link up. I'm sorry, Aiden. So let me do that right now while we're waiting for just 1 second. I'm gonna go to Instant Relief. I'm gonna go to my videos. Okay. So let's open up the slideshow from yesterday and please jump into slide number 6 for me. We're going to get right in. We're going to get started. Let me go to classroom. Recording from yesterday. Okay, so Aiden, that is now in. If you need it, and I mean, you can watch it at the end. I'm gonna get started. Here we go. No, I hate when that happens. So you'll just get an email update that I updated the stream. I added the recording from yesterday. I uploaded it to YouTube and then I completely forgot to copy and paste the link. So let's take a look at our activity for today, okay? So we're opening up and we're finishing this slideshow from yesteryear. If we look at this guy here, we talked about writing functions yesterday, writing statements about functions. And when we write statements about functions, we write the statements as what is a function of what? What did we say when we were writing functions? How did we describe functions? Is input a function of output, or is output a function of input? What's it going to be? Is input a function of output, or is output a function of input? Nice job, Claire DeLune. Nice job, Luke. Output is a function of input. Very good. Output is a function of input. Okay? And remember, input is the value that you know that you are plugging in. Yes, Haley, nice job. The output, so the input is the value that you know, the value that you're going to be plugging in. The output is the value that you're going to get once you solve it. That output, that answer that we get, that range that we get to that domain that we're plugging in, okay? So when we're talking about these pieces here, we were able to look at Jada and we were able to look at the combinations that she had of quarters and dimes that added up to a total of $12.50. Okay, and the way that we expressed that was by writing this equation right here. My question, this isn't really the most applicable, but I'm just asking because it's important. What form is this original equation written in? What do we call that? When the x and the y are on the same side, what form is that? It's not slope-intercept. Yes, Claire. It's in standard form, Julia. Yes, it's written in standard form. First thing I'm going to say, I am so impressed with how active everybody is right now in this chat. You guys have been the most active of all 4 classes today. Keep it up. I'm really impressed. Yes, this guy is written in standard form. And when we have to create a rule, we isolate for what? We isolate our equation, right? We take the original equation and we isolate for what? We set it equal to our input or our output. When we wrote that rule there. Very good. We isolated for our D, which represented our output. So when we're given an equation and it asks us to create a rule for the function, if we have to rework it, isolate for one of the variables, you're always going to isolate for that output, that in this case, the D, okay? Very good. And the reason that we said that this input was quarters, was the number of quarters, was because that is the value that we were given when we looked at the description here. We know that we have 4 quarters, 10 quarters. We had to calculate the output, which is our number of dimes. Okay, so to calculate this rule, we took the standard form equation that we were given at the beginning and we isolated it for our output. We solved it so that D was by itself. We had a single D. Okay, then when we were talking about how did we find those answers for 1 and 2, was we just plugged that 4 in for our Q and solved to get our D. Not a big deal. Awesome job. How do we feel when we just reviewed that for a few moments? Do we feel good with this topic that we did the other day? Because we're going to do almost identical the same thing here. Moving forward. Good. Thank you, Claire de Lune. Let me know if I'm going too fast. Okay. Haley is good too. Thank you for letting me know that, Haley. So now I want you to think about and I want you to look at the statement on number 3. The statement that we're going to be looking at on number 3 is the number of dimes a function of the number of quarters? If you were describing this function to somebody, keeping this in mind, is this the way that you would write it? Would you write it as dimes is a function of quarters, or is that incorrect? I want you to think about that first. Is that a correct statement saying that dimes is a function of quarters? Answer that question here, yes or no. If you said yes, tell me again what we think the rule is. If we think no, tell me why that is not the way that we would write that function statement. Let you take 1 minute right now to independently do that. Nice job, Claire de Lune. Is this a true statement? The number of dimes is a function of the number of quarters. I got Claire giving me an answer. I want to see what everybody else thinks. Is that a true statement? The one that's underlined in red. Nice job, Haley. Thank you. Nice job, Dylan. Thank you, Julia. Nice job, Caleb. Very good, guys. So let me get what people are thinking. I had 5 friends put it in the chat. It's a yes or a no. Is this the correct way of saying this function statement? Based on the information we were given on the last slide, is it appropriate to say dimes is a function of quarters? Thank you for that. Dylan, can I have you on mute and can you tell me what you thought? Is it correct, yes or no, and why?
I think it's correct because I think that output's a function of input.
Good, because we always write it as output is a function of input. And remember, we were solving for dimes. And so if you're solving for a number, that is your output. That is your range. When you're given a number, we were given the number of quarters. That is our input or our domain. Okay, awesome job there, Dylan. Fantastic work there, my friend. So if we look and we said that, yes, this is a function, dimes is a function of quarters, Claire said that our rule was D is equal to 125 minus 2.5q. Do we agree? Do we agree with this rule? Very good. Haley, I have a question for you. When we write a rule, we isolate for what? Or we rewrite our equation so that what? What do we think? You want to unmute and let us know, Haley? Oh, very good. We isolate for our output. So sometimes we're going to be given an equation, and when you have to write the rule, you need to isolate or do moves to it to get that output by itself. We isolate for our output. Very good. Nice job on that. Awesome job. Does everyone see why we said, yes, this is the function statement for this story? Or if you don't, let me know in the chat. Say like, I don't know. I'm not sure. Very good. We're always writing a function statement as output as a function of input. Don't range as a function of domain. Dependent as a function of independent. Okay? We're always talking about functions in the terms of output is a function of input. Nice job. Let's take a move forward. I'm going to leave that statement up there at the top because it might be helpful with the next slide. So now, for the next slide, we're going to be doing some independent work. For the next slide, we are given the same situation, but this time, we have the same situation, same equation that we're starting with. This time, though, we're given the number of dimes that Jada has. You need to do four things on this slide. First, you need to figure out if she has 25 dimes, how many quarters does she have? If she has 30 dimes, how many quarters does she have? You're going to answer those two questions. Then you are going to isolate the original equation for your output. So you're going to tell me in general, what is your input value? Don't give me a number. Say quarters, dimes, miles, feet, hours. What is the input going to represent? What is going to represent the input? And what is going to represent your output? Then I want you to manipulate that original equation, isolating for your output. Write your rule here. Then I want you to look at the function statement down in number 6. Tell me, is it correct? Yes or no? And tell me if it's correct, you tell me the rule. If not, you tell me why. There's a lot that you're doing. You're completing this whole slide. I'm giving you 5 working minutes to work on this right now. Let's get started. Actually, I'm going to give you 4. There's a lot to do here. I understand that. You're taking your time. You're getting what you can get done. Everybody's doing great. We have 2 minutes and 30 left. Remember, you're probably not going to get through all of it, and that is okay. I mark races here? I don't know if I did. Okay, Jessica's here as well. So I'm just missing. Did Melina make it? Oh, no, Melina didn't make it today. Where is Melina? Guys, was Melina here this morning? She was? Oh, no, where's Melina? And Kaden. But Kaden, okay. So I'm going to shoot her an email. I'm going to see where she is. We're wonderful. We're taking another minute and 27. You're doing great. Thank you for letting me know that, Claire. You are the best. Okay, taking another minute and 11. Sorry, that was a lot of updates. Wonderful. We're taking another 28. Awesome job, guys. Oh no, I wrote that in the wrong spot. Another 11. Okay, let's come back together. I know you probably didn't get a chance to finish, and that is okay. Let's take a look. Sorry, guys. Sorry. Okay. So first things first, I'm the realist. What is the input here? Remember, we were talking about input in a general sense of the word, not an exact value. What was our input? Julia, why are you thinking number of dimes was our input?
I said number of dimes because we know the number of dimes we have.
Very good. She said the input is the number of dimes because that's we know how many dimes we have. Awesome job, Luke, Haley, and Claire DeLune as well. Perfect. Now let's take a look. What is our output going to represent in general? Ooh, Aiden Gesselman was right on it. Nice job. Aiden, do you mind unmuting and telling me why did you choose the one that you chose there?
Because this asks us how many quarters we have.
Very good, because that's the value we're looking for. We're calculating. It's going to be the number of quarters. Very good job there, Aiden Gesselman. Thank you for that. Also, Julia, Dylan, Luke, and Claire, and Haley. Awesome job. So let's think about, before we talk about the rule, if she has 25 dimes, how many quarters does she have? What did we calculate for that one? Nice job, Haley, Julia, Claire, and Luke. Awesome job. Fantastic job, Dillo. Perfect. It's going to be 40. Very good. Because when you plug 25, you can do it two ways. You can find your rule equation here, plug that value in for the dimes, and then calculate your Q. Or you can plug your 25 into the original equation and solve for your Q. You're just going to have to do a little bit more moving when you do that. So it's going to be 40 quarters when she has 25 dimes. Now, 30 dimes, how many quarters is she going to have? Nice job, Haley. Nice job, Claire. Nice job, Fizza. It's going to be 38 quarters because when you plug in, how did you get your answer? You plugged it in and you solved it. Yes, Julia, Fizza, Luke, awesome job, Claire DeLune. Very good on those. So then, now I want us to think about here. First things first. How did we get what that rule equation was? What did you have to do to figure out what that exact rule is going to be? Who wants to unmute and let me know? Fizza, can you unmute and let me know? How did you figure out what that rule was going to look like? Very good, Claire.
I solved the equation and then I wrote it down as Q equals 12.5 minus 0.1D.
Very good. So she said to herself, I need to solve or isolate for that output, right? So I need to solve to get that Q by itself. So she took that equation of 0.1D plus 0.25Q is equal to 12.5. So can I have Claire, can you unmute and tell me what would be the first thing you did first here with this to get the Q by itself?
I subtracted 0.1D from each side.
Very good. You first want to move that D to the other side by subtracting 0.1D minus 0.1D. Very good. We're left with 0.25Q is equal to 12.5 minus 1.1D. Okay. Now, Julia, do you mind unmuting and telling me what do we have to do to get that Q by itself to be a single Q?
What we have to do is we have to plug in the number of dimes we have or quarters.
So we would do that. That would be our next step. But first we need to get it so that, see, if we look at it right now, we have a 0.25Q, but I want to isolate it so that it's just a single Q. What do I have to do to get that Q all by itself?
Divide by 0.25.
Very good. I have to divide by 0.25. And when I'm dividing, Caleb, what do I have to divide? I'm not just going to divide each side by 0.25. What am I going to divide by 0.25? Nice job, Claire.
You would divide each term.
Yes, Caleb. Yes, Haley, Claire, and Luke. You're going to divide each of the terms by 0.25. And we would get a rule of what? Q is equal to, very good, Claire DeLune, 50 minus 0.4D. Very, very, very good. Awesome job. And I love the fact that so many people were really specific and they said dividing each term. Awesome. Yes, dividing each term by the 0.25. So if we looked at this function statement down here, is the number of quarters a function of the number of dimes? What did you think for this piece down here for number 6? Is that a true statement? Nice job, Claire. Nice job, Haley. Nice job, Julia. Do we think this is a true statement? Meryl, what were you thinking, dude? You can let me know in the chat. Did you think that this was a true statement? Wonderful. This is a true statement because we write function statements as what is a function of what? Go ahead, Landon. Function statements are written as output as a function of input. Very good. So my rule, once again, we said is 50 minus 0.4D is equal to Q. Nice job. Very good, Julia. Very good, Claire DeLune. Perfect, perfect, perfect. Awesome job. Okay. Fantastic. So let's take a look at this last activity that we're going to be looking at for today. Everybody did so well with that. I'm so proud of you guys. Let's take a look at slide number 11. Okay, we're jumping down because 10 has the directions, but I think it makes more sense if we just look at 11. Okay, so on 11, we have a bunch of stuff here. Your job, let me tell you what your job is. Your job is to, in the margins here, so like here and here, I have 4 statements that represent a scenario. Your job is to, with each one of these statements, statement A, you need to find the function diagram that matches that statement. You need to write the equation for that statement. When the input is 5, what is your output value going to be? What is your independent or input? What is your dependent or your output? Okay. So let's do description. Do we want to do one together, or do you guys want to just do them independently? We'll do one of them together, and then we'll do the other 3 independently. Okay, so if we look at description A says the circumference C of a circle with radius R. So we're solving for the circumference of a circle with a radius R. Which one of these diagrams here, A, B, C, or D, might be talking about calculating the circumference giving the radius? Nice job, Aiden. Nice job, Haley. Nice job, Claire. Nice job, Julia. What were some indicators that that was the one that matched it, Dylan? What told you?
It has the same variables.
Very good. The variables are the same. I also said this guy has a pi in it, and that's the only one that's really talking about a circle. So that would be the only one that would have involve pi. Good. So then if we look at the equation for this one, we are going to say that output is equal to what's inside that input, the function machine. So we would write C is equal to what's inside that function machine, 2 pi r. Okay? Now what you're going to do is you're going to plug 5 in there for r, and you're going to figure out what's your output going to be. So you're going to rewrite this equation. You're going to say 2 pi times 5, which means the same thing as 10 pi. If you calculate what's 10 times pi, or 10 times 3.14, we get, let me try it again, 10 times 3.14, we get 31.4. So you're going to plug 5 into that equation to figure out what your output is going to be. Your independent is your input. Which variable represents our input here? Look in the function box. The furthest left is our input. The input for this one is the letter R, or the radius. The output is that furthest right here, the C circumference. Okay, so I want you to take, listen, I want you to take 3 minutes right now to match the last 3 remaining ones here, and calculate all these pieces that it asks you to. Take 3 minutes right now, please. Nice job, Claire. Thank you for that, my friend. Another minute and 45. Oh, it's written right there. I don't know why I spelled it wrong. Okay, you're taking another 56. Ooh, actually, I'm going to go do that. Okay, we're taking another 17 seconds. Get ready, we're starting right with B. Okay, here we go. Let's come back together. Let's get started. Let's take a look here. We have description B here. Which one of these diagrams did we say that description B went with? Description B went with diagram B because we're talking about, we have this value 60. We have the variables T and D. That's the only one that has those variables in it. Very good. Nice job, Claire. Thank you. Also, Aiden. So then if we wrote the equation, we take the output, D, and we set it equal to what's inside the function machine. D is equal to 60T. You're not just going to say 60T. You need to set it equal to that letter, that variable for the output. Then when you plug 5 in for T and solve, you get a value in output of 300. Okay, now if we're talking about the independent variable, which one of those variables represented the independent variable or the input? Very good, it's that T time in hours, good. Then if we're talking about that dependent variable, that output, that range, which variable represents that? Nice job, Haley. Nice job, Claire DeLune. It represents the D distance. Okay. Now we're looking at C. C is talking about the tripling a number and then subtracting 4. That C diagram is the one that represented that one. It had the 4, it had minusing 4, it had the variables X and Y. Very good. When it doesn't tell you what variable letters you're talking about, you're going to revert to X and Y. Good. If you write it as an equation of output equal to what's inside your function machine, Y is equal to 3X minus 4. What did you get for an output when you had an input of 5? Nice job, Claire. What did we get for an output when we had an input of 5? Let me know in the chat, guys. It's going to be 3 times 5, which is 15 minus 4. Don't forget to minus the 4, Julia. It's going to be 11. 15 minus 4 gets me 11. Okay? So, awesome job on that. Independent variable, that input value or that domain was represented by the letter X. And we could say X is a number. Okay, the dependent was represented by the letter Y, or triple a number minus 4. Okay, last one, letter D, description D, talking about volume, is connected up to diagram A. I don't know why I just drew that on there. It connects to diagram A. Okay, if we write it as an equation of your output equal to what's inside your function machine, V is equal to S cubed. That's a 3, by the way. V is equal to S cubed. You could have written it as V is equal to S and then the little caret and then the 3. That would have meant the same thing. Nice job, Claire. Input, when you input 5, you're going to get an output of 125. Your independent or your input or your domain is which variable? Our S, nice job, Haley and Claire. Our S, which represents our side length. And our output is what variable? Very good. Our output, our range, our answer is going to be the volume. Okay? Awesome, awesome job. It says that you need to, for afternoon work, complete the rest of this slideshow. We completed everything we needed to. We're going to do the discussion on 12 tomorrow. I'm going to pull that up and we're going to do it tomorrow so you can turn this in. The assignment for this afternoon, let me pull it over, give me like literally 10 more seconds to explain and then you're good to go. So if you take this guy here, and we look at the assignment for today. Someone already turned it in. I don't know how we did that, but we have 2 things we need to do here. 30 minutes of Alex time. Even if you completed your 30 minutes for the week, I want you to push and give me 30 more minutes. Number 2 is this slideshow. There is 1 slide on it. You're looking at a description, a function description. You're creating a rule. You're labeling your inputs, outputs, creating an equation, and finding some output values given the input. This slide should take you 5 minutes at most. Okay, I will see you all tomorrow. Send me emails if you have questions. Listen, you guys did amazing today. Have a good one. Bye, Caleb. Bye, everybody. I will see you tomorrow. Bye, Brady. Bye, Aiden. Bye, Claire. Bye, Aiden. Thank you. Bye, Luke. Bye, Claire. Bye, Jason Derulo. Bye, Dylan. Bye, Jessica. I was just going to say that. Bye, Jada McGibbon. Are you there, Jada McGibbon? Bye. 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 Jada McGibbon, are you there, buddy? Oh, no, you're not there. I will see you tomorrow. Okay, bye, bye, Jaden. Remove. I'm going to stop sharing my screen and we are done for the day. Yes.